Hello, everyone. I'm Zisu Li from the Hong Kong University of Science and Technology. Today, I'm very happy to present my work exploring the opportunities of AR for enriching storytelling with family photos between grandparents and grandchildren. This work was conducted in the HealthcareWorkers Apex Lab and collaborated with the Pervasive Human-Computer Interaction Laboratory at Tsinghua University. Our work was really motivated by the primary mode of reminiscence activity, intergenerational storytelling with family photos. Grandparents share their personal experiences with their grandchildren to preserve cultural connections and foster closer relationships and intimacy with their grandchildren. Within this process, family photos, which are old physical photos, can be a trigger or a medium to facilitate the communication between the storyteller and the listener. Different technologies have been considered to assist intergenerational storytelling, such as 2D technologies or VR. However, many existing 2D technologies for augmenting photos require storytellers to hold the device, which occupies one or both hands. Furthermore, storytellers must switch back and forth between physical photos and the augmented content on the tablet user interface, which limits immersion and may cause distractions. Compared to 2D technologies, 3D technologies such as VR or AR allow storytellers and listeners to interact with story elements in an immersive environment, which may provide a richer and multimodal information exchange during storytelling. Compared to VR, which blocks users from the physical world, AR can enrich story elements by augmenting a physical photo with digital content beside it, which allows storytellers and listeners to access both the physical and digital worlds simultaneously. So our goal is to investigate how AR could be used in assisting intergenerational storytelling. In this work, we conducted a formative study to identify the characteristics of photo-based intergenerational storytelling. Then we used the AR probe study to uncover 7 ways of leveraging AR to assist intergenerational storytelling. And we proposed the design implementations and possible ways for designing AR-enabled photo-based intergenerational storytelling. In our study, we first asked our participants to conduct in-person storytelling, followed by a semi-structured interview to find the characteristics of photo-based intergenerational storytelling. Now we conducted an AR probe study, which include AR probe tryout session and a co-design workshop session between grandparents and grandchildren. This process is to uncover potential ways of leveraging AR to assist intergenerational storytelling. Now I will use a demo to illustrate the AR probes we used in our study. Method in HoloLens 2. A virtual ray is cast from the center of the palm for both left and right hands, which intersects with a target object or widget and renders a dot-like cursor on the screen. In the picture, the grandparent pointed to the character to let his grandchild know who is he. Probe 2, object manipulation. The user could manipulate an object, for example, a 2D UI widget or a 3D model in the virtual environment with 2 interaction methods. As the left shows, for nearby objects, the user could directly manipulate the object by pinching, grabbing, and dragging with their hands. As the right shows, when manipulating distant objects, the user uses an indirect method with hand raised by pinching and grabbing. Probe 3, 3D model display. The user could simply press the model button to invoke the 3D models of the elements related to or that appeared in the demonstrative photos, such as old objects and characters. For the left video, the photo was taken in a primary school classroom in the 80s. The probe showed a desk and a bench model. In the right photo, which was taken in an old park in the 90s, the probe showed a one-boat model and a wooden pedal like the photo demonstrated. Probe 4, sound effects. The user could press the sound button to play background sounds related to photos. Like the video shows, the sound effects were the cries of retailers in a wet market to match the photo taken from a wet market in the 80s. Probe 5, reminiscence. Press the memory button to show a related photo with the original photo. In our example, the original photo showed a scene while the grandma and the mother were playing on the beach. When the grandma pressed the button, a photo of the mother and the daughter in a similar scene, like a beach, was displayed beside the original photo. Probe 6, restore. Press the restore button to make image colorization, image super resolution, or image completion. In this video, the black and white picture of a wet market was restored in the color by Probe 6. In the following part of the participatory design process, the participants would visualize their ideas or suggestions about the probes and propose new ideas about AR storytelling. In total, we collected data from 10 pairs of grandparents and grandchildren. We conducted a thematic analysis for 20 hours of video recording with supplementary materials from the study, such as field quick notes from researchers, photographs of the participatory design activities, and digital copies of the sketches created in the co-design activities. Our findings include two parts. The first is about characteristics of grandparents and grandchildren performing photo-based intergenerational storytelling. We summarize the three aspects. One is the story content, such as themes and consequences. One is the grandparents' presentation skills, such as oral language, tone, facial expressions, and body language. And one is the organization strategies for key points in a story. The second part is the ways of using AR to facilitate photo-based intergenerational storytelling. These ways were proposed by our participants to assist or augment the process of intergenerational storytelling related to the characteristics found previously. Here I introduced some of our interesting findings. First, we found that grandparents kept revising and qualifying descriptions and tried to record the details of the old times as much as possible, with a strong desire to accurately describe things they mentioned during storytelling. In this way, some participants mentioned that the digital content, such as some 3D models representing the story elements shown by AR glasses, could help them better explain relevant activities, events, or persons for listeners to comprehend them visually. Okay. Next, we found that change is a frequently mentioned topic for intergenerational storytelling. Participants tend to talk about change and make comparisons in technologies, society, people, and artifacts in their stories. In this way, they would like to leverage physical objects, and AR augmented similar content to explain relevant story elements. Specifically, grandparents proposed to leverage more daily physical objects such as cups, paper, and clothes to help explain similar items in old times. They want to provide references or alternative editable models in AR to describe items. We also found interesting characteristics about the story structure told by grandparents that, as the picture shows, typically they started from an element in the photo and iteratively introduced the supplementary information, for example, the usage of the item and side stories. As a result, such a narrative structure generated many branches and child nodes of side stories that gradually detached from the main storyline. In this way, some participants expressed that AR could provide indicators like annotation, timeline, and keywords for grandparents to keep track of their main storyline to tell stories more organized. For more details and discussion, please refer to our paper. Thanks for listening. Feel free to ask questions or contact me for further discussion. Sorry for time.
So in the interest of time, we will move on to the next presentation. Thank you very much.